Very good morning, students. Today we are going to learn about implicit differentiation. Before learning this implicit differentiation, first let us learn about explicit function. There are two functions, explicit function and implicit function. So there are two functions, explicit function and implicit function. So let us understand what is explicit function. So by taking an example, let us understand first. Y square x yx plus x square y square plus x cube is equal to 0. So let us suppose this is a given function. So like if I make it as in terms of like this, y square if I take common, it is left with x plus x square is equal to minus x cube. So y square is equal to minus x cube by x plus x square. So y equals to root of minus x cube divided by x plus x square. So let us take another example here. Xy square plus xy plus x cube is equal to 0. So in this I can take y common, xy plus x is equal to minus x cube. So y is equal to minus x cube by xy plus x. Now, if you observe these two examples, example 1 and example 2, here y we have expressed entirely in terms of x. So y is equal to f of x. So if we are able to express a function y in terms of x, then we can say that it is an explicit function. Next, implicit function it means that here if you see here y is there, but here also y is there. So total the function y is unable to be expressed in terms of x. So the function y we are unable to express this function in total in terms of x. So that's the reason we are going to call this function as implicit function. So a function which I can express in terms of x, I have to call it as explicit function. A function which I am unable to express it in terms of x, I have to call that function as implicit function. So for this implicit function, in order to solve this implicit function, then I have to use implicit differentiation. Okay, let me write the definition. A function f of x, f of a comma b is said to be explicit function. A function is said to be explicit function if we can express y in terms of x. So in the first example, I have expressed y in terms of x, so I can call it as explicit function. So that is y is equal to f of x. Next, based on the second example, a function f a comma b is said to be implicit function if we cannot express y in terms of x. So if I am able to express y in terms of x, I will call that function as explicit function. If I am unable to express, I will call it as implicit function. So next we will have, in order to solve this implicit function, we have come up with the idea that implicit differentiation. Process of solving the implicit function is called implicit differentiation. Implicit differentiation. So for example, x power 4 y cube plus xy plus x square y square is equal to 1 minus 2x. So this we can say that it is an implicit function. Why? Because we cannot express y in terms of x. So for this to solve, we need to make for each and every function as derivative. Let me say independent variable, derivative of x power 4 y cube plus derivative of xy plus derivative of x square y square is equal to derivative of 1 minus 2. So the way of making this procedure, we are going to call it as implicit differentiation. So this is about implicit differentiation. Next, we have logarithmic differentiation. Second one, logarithmic differentiation. A function in the form of whose base and exponent both depend on independent variables. Both depend on independent variables. So such type of function we are going to call it as, we call logarithmic function. Logarithmic function. So that means y function should be x to the power of x, or as y to the power of sin x. Whatever the function, here it should be power to the power base and power should be there. If it is there, then what we have to do? We have to apply log on both sides. So apply log on both sides. So by applying log on both sides, we are going to solve this function. So we are going to call that function as a logarithmic differentiation function. So few more examples. So this logarithmic function we can use in this case also. Let us suppose a function is given like this. Y is equals to 1 plus x square into 1 plus 1 minus x cube into 1 minus x power 4 divided by x power 4 minus 5. So in this case, in order to solve it, or let us take another function x square plus 4. In order to solve this function, so definitely it is better to go with logarithmic function. Since we cannot solve by u by v method, since it is a quotient rule also, but again in this case it will apply product rule. So it will make multiple times to use differentiation. To reduce our differentiation, we can go with logarithmic differentiation. Since it is in the form of a by b, by applying log on both sides and differentiating with respect to the independent variables, we are able to solve in a less differentiation time. Now let us see some exercise questions. Okay students, now we will see exercise 10.1 first question. y is equal to x to the power of cos x. So power and exponent, if it is there, I said that we need to use logarithmic differentiation here. So in order to use logarithmic differentiation for let us say the given function y is equal to x to the power of cos x. Second step, apply log on both sides. So if we are applying log on both sides, it will be log y is equal to log of x to the power of cos x. So this will come in friends, it will be cos x into log x. Here log x. Now differentiation with respect to x. Differentiation double argument with respect to x. So if I do differentiation with respect to x, here it will be log y differentiation is 1 by y dy by dx is equal to, it is in the form of product rule uv. So product rule will be given as uv dash plus vu dash. So first function I will use cos x d by dx of log x plus second function log x as it is d by dx of cos x. Okay, next 1 by y dy by dx equals to cos x. Derivation of the log x is 1 by x. So 1 by x cos x plus log x. So derivative of the cos x is minus sin. Minus sin. So if I transpose this to the other side, it will become dy by dx is equal to cos x by x. Okay, plus into minus log x sin x into 1. But according to our differentiation, everything should be in terms of x. So here y is there, so we can replace y with a given function. So cos x by x minus log x sin x into y is x to the power of cos x dy by dx. Next, let us see the second question. Y is equal to x to the power of log x plus log x to the power of x. So of course we have to use logarithmic differentiation, but here we have two different functions. So let us assume like this. Let u and u. Let y is equal to, let u is equal to x to the power of log x. V is equal to log x to the power of. So that can be written as y is equal to u plus v. If I differentiate with respect to x, dy by dx is du by dx plus dv by dx. So first let us find out differentiation of the u with respect to x and differentiation of the v with respect to x. So first let me take the u function. So in this u function, since it is in the power to power, so I need to apply log on both sides. So like this, u is equal to x to the power of log x. Apply log on both sides, so it will become log u is equal to log of x to the power of log x. Like this log x will come in front, so log u is equal to log x into log x. Differentiation with respect to x on both sides. So it will be 1 by u du by dx. So this can be written as log x square. So we can write here log x square. So log x square means it will be 2 log x. So differentiation of the log x will be 1 by x. So du by dx is equal to 2 log x divided by x into u. So we know the function of u, that is 2 log x divided by x into u function is x to the power of log x. So this we have differentiated with respect to x du by dx. Next, we will differentiate in the same way with respect to v. So we will do next v. So the given v function is log x whole to the power of x. Apply log on both sides. It will be log v is equal to log of log x whole to the power of x. So this will like come in front. So log v is equal to x log of log x. So if I differentiate with respect to x, on both sides, so 1 by v dt by dx equals, it is in the format of product of u v. So first function as it is derivative of the second function 1 by log x into logarithmic of the derivative 1 by plus second function as it is log of log x, derivative of the x is 1. X gets cancelled. So dv by dx is equal to 1 by log x plus log of log x into v. So we know already the v function that we can replace here. Now let us substitute these two values. So we are going to get dy by dx equals du by dx we got it as 2 log x by x into x to the power of log x plus dv by dx 1 by log x, let us put in bracket 1 by log x plus log of log x into the y value. What is v value? Log x whole to the power of x. So this is the math. Everything you can see in terms of x. Let us see the fourth question. X to the power of y is equal to y to the power of x. So that is the power. Let us apply log on both sides. Apply log on both sides. So if I apply log on both sides, it will be log x to the power of y is equal to log y to the power of x. So y log x equals to x log y. Now differentiation with respect to x. Respect to x on both sides. So if I am doing differentiation with respect to x on both sides, it is in the format of uv. So first function as it is derivative of the second function 1 by x plus second function as it is, so derivative of the first function is dy by dx is equal to first function as it is derivative of the second function is 1 by y into dy by dx plus second function as it is derivative of the first function is 1. Derivative of this is 1. So this can be written as y by x plus log x into dy by dx equals to x by y dy by dx plus log x. So we'll transpose dy by dx to one side. So log x dy by dx minus x by y dy by dx equals to log y minus y by x. Y by x. So in this two we can take dy by dx is common. So we are left with log x minus x by y equals to here x log y minus y divided by. So here LCM will be y. So here dy by dx is equal to, let me transpose that as x log y minus y by x divided by y to log x is y log x, y log x minus x divided by y. So this will be multiplied in the numerator, this will be multiplied in the denominator. So the answer will become y into x log y minus y divided by x into y log x minus y divided by. Next, let us see the fifth question. Cos x whole to the power of log x. So let us assume this function as y. Y is equal to cos x whole to the power of log x. So let us apply log on both sides. So log y is equal to log of cos x whole to the power of log x. So this log will come down. So log y is equal to log x into log of cos x. So let us apply differentiation with respect to x on both sides. So if I apply differentiation with respect to x, 1 by y dy by dx equals, it is in the format of u. So first function as it is log x into derivative of dy by dx of log cos x plus second function log of cos x as it is into derivative of dy by dx of log. So 1 by y dy by dx is equal to log x into derivative of the log x is 1 by x, that is 1 by cos x. Derivative of the cos x is minus x plus log of cos x into derivative of the log x is 1 by x. So 1 by y dy by dx is equal to, so this can be written as sin by cos, which is tan, so minus tan x log x plus log of cos x by x. So if I transpose this to the result, it will become dy by dx equal to minus tan x log x plus log of cos x by x into y. So we know the y value as cos x whole to the power of log x. So that is minus tan x log x plus log of cos x by x whole into cos x whole to the power of log x. Let us see exercise 10.4, sixth question answer. So it is given a circular equation. So given x square by x square plus y square by b square equals to 1. So differentiate with respect to x. With respect to x on both sides. So derivative d by dx of x square by x square plus d by dx of y square by b square is equal to constant derivative 0. Now here 1 by x square is constant term, so derivative of x square is 2x into 2x plus 1 by b square is common, so derivative of the y square is 2y dy by dx is equals to 0. So here the equation is 2y by b square into dy by dx is equals to minus 2x by a square. So dy by dx is equals to minus 2x by a square into b square by 2y. 2 gets cancelled, minus b square x by a square root. That is dy by dx. So this is the derivative.